here for another educational video in statistics. Can't wait. So excited to be here. So today we're going to talk about the cumulative property and how it works and how to be able to do calculations for it. The difference between left and right makes a lot of difference in this class. Oh, hi.
Hello.
What were you doing?
Oh, you know, just lying around.
You want to help me with an education video?
Did you say educational?
I tried, yeah. It's a big word.
Nope.
Okay, bye.
Bye.
Anyways, I guess I'm on my own, so I'll just try and control a mouse with my little tiny arms. And then I'll also try to write on a whiteboard and explain everything. This is probably not going to go well. I really wish I had backup. Hi. Do you want to do an educational video with me? No, but I also like to help out, so okay. All right, do you think you can control the mouse? Did she say mouse? Yeah, I can control the mouse, absolutely. Should I be worried? No, why? Nom, 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 nom. It's not that kind of mouse. Put it down. Right, sorry. Yeah, what do you need me to do exactly? Just click things and like draw. You want me to draw? I'll give it a shot. Okay, we'll try again. I'm just gonna pause this recording for a second. Why? Is it not going well? And we're back. Okay, so here's a problem from class. It's about washing our hands. Very important thing to do right now. And we're gonna try and figure out how to answer all the questions to it. The first thing we have to worry about is whether it's exact, less than, or more than. Right and left matter a lot in this problem. Okay, so this is a binomial distribution problem. We have a sample of 20, right here, 20 adult Americans. And we have to figure out all of these probabilities, A through G. Okay, so let's just start by reading the problem out loud. That's where you should always start. Read the problem. In the Healthy Hand Washing Survey conducted by Bradley Corporation, it was found that 64% of adult Americans operate the flushers of a toilet in public restrooms with their foot. Interesting. In a random sample of 20 adult Americans, find and interpret the probabilities of the following. Okay, so I have this cool number line down here at the bottom that runs 0 through 20. So in this problem, we're asking people if they're flushing the toilet with their foot, and the number line is going to represent over here on the 20, everyone we asked flushed the toilet with their foot, and over here on the 0, nobody we asked flushed the toilet with their foot. Okay, so let's try problem A. The probability that exactly 12 American adults flush the public toilet with their foot. Okay, exactly, that's a keyword, and we have a slide for that. Oh, what a relief. Okay, so exactly, it's down here, it's the equal sign. This is the only line on the whole table where you don't have to worry about whether or not it's cumulative. Okay, so all of the other lines, they talk about cumulative. Okay, but this last line has an equal sign. It's the only one that's not cumulative.
Moo?
No, cumulative.
Cumulative?
No, cumulative.
Moo?
No. Cumulative. It means everything that came before.
Moo?
No.
Moo.
No. Cumulative. It's a word that means all the things that came before are included. Like if the final's cumulative, then it's on everything that happened in the class, not just the last little chunk of the class.
Moo?
I'm gonna have to ask you to leave. You're a distraction.
Moo.
Okay, so cumulative means that the calculation will give you this value and all the values that came before it. Not cumulative means that it'll give you exactly one value and the value that you're looking at. So we have symbols This is greater than or equal to, greater than, less than or equal to, and equal to. Okay, for almost all of those symbols, we have to use cumulative because we care about more than one thing. But on this very last row, it's the equal sign. We only care about one thing, and so we get to just use the exact value. This is exactly 12 adults. So let's go ahead and type in our equal sign for exactly. This is exactly equal. So in Excel, we'd be able to use the binomial distribution without the cumulative property. I'm not on screen. Without the cumulative property. Equals binom dot dist, open parentheses, the number we care about, which the problem says is 12, the number of people we asked, which the problem says is 20, the probability that they said yes, which the problem says is 64, and whether or not we need cumulative, and we don't, so we'll say false. If we were to say true to that, then it would find 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, and add them all up. It'll find the whole left side of the number line below. So when we say not cumulative, it finds the value or the probability for just 12. But if we do say cumulative, then it'll find the value or the probabilities for 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, the whole left side of the number line. All of this. Thank you, Kitty. No problem. Okay, so let's read the next problem and see if we need the cumulative property. Alrighty, here we go. The probability that no more than 12 adult Americans flush public toilets with their foot. Oh, that's a no more problem. Let's go to our cheat sheet. Okay, so no more than, oh, that's right here. No more than, that's a less than or equal problem. So let's go look at the number line. So this probably no more than 12 adult Americans flush. Okay, so no more than. I want no more than 12. So 12 is okay. 12 is not more than 12. Okay. 12 is okay. All right. 13. 13 is definitely more than 12. And they said no more than 12, so not 13. Oh, okay. So it looks like I just need this left-hand side. I already know how to do that. It'll be the same as the top, but I just have to say true to cumulative. Okay, so I'll go type that in now. So this one is equals binom dot dist. 12 is the number we care about. 20 is how many we asked. 0.64 is the probability that they said yes. And now I'm going to say true because I want the whole left-hand side of the number line. Yay, we did it. Okay, we could do this. We gotta keep going. Okay, so then the probability that fewer than 12 adult Americans, wow, that's almost the same as B. What's the big difference? No more than or fewer than? Let's go look at a cheat sheet. Okay, fewer than. Oh, that's the left two. Oh, but, oh, okay, I see. Okay, so it says fewer than 12. So then 12 isn't okay anymore. So 12 is not fewer than 12. Oh, but 11 is fewer than 12. And so it wants this whole left-hand side. Okay, so we did that in the problem before, but we used 12. This time we need 11. Oh, I should erase some of that. That got messy. Let's go clear all that. So 11 is okay, and 10 is okay, and 9 is okay, and we'll just keep going that direction. Cool. So now I just got to go edit that thing that I did for B, and I'm going to switch it to an 11. Okay, so here, this is equals binom dot dist of 11 and then 20. How many people we asked? The probability they said yes. And now I still want it true because I cared about 11 and everybody that was less than 11. Yay! Well, I'm backwards. That's embarrassing. Fix that. Okay. Yay! We did it again. Okay. So, okay. So now we're going to do D. The probability that no less than 12. No less. Okay, so not less than 12. Let's go look at our cheat sheet. No less. No less. Less than or equal to. Oh, no less. It's up at the top. No less than. That's greater than or equal to. Okay. So let's see. No less than 12. Okay. Let's see. Well, 12 is not less than 12, so that's okay. It's not less than 12. 11 is less than 12, so they don't want that. They want no less than 12. So 13 is okay. Huh. All right, so I want all of this area. Oh, okay. Well, so far I only know how to find the other side. I only know how to find all this. How do I find the right-hand side if I only know the left-hand side? Oh, I know, it's that one thing.
You look great today.
Oh, thank you. That's a nice compliment. Oh yeah, that's what it's called. It's called a compliment. So if we use the complement, then we can figure out the right-hand side, even though we can only do the math for the left-hand side. Yes! You're a genius, doggy. Okay. Clear all my drawings. Okay, so that means that if I find, what was it? With no less than 12. Okay, so if I find this, and I add it all up, and I just subtract that total from 1, then I'll be able to figure out the right-hand side. Okay, cool. Let's go do that. Okay, so I need to subtract from 1 equals 1 minus the binom dot dist for all of the numbers I don't want. And I didn't want 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And rather than type all those, I can just do 20, run the problem, 0.64. Okay, and then I'll say true. Okay. So that, oh, I'm backwards again. So that math will take out all of the bad values and subtract them away from the total, and then I'll just get the values I wanted. Yes! Okay, so D is done. So now E, the probability that more than 12 adults. Oh man, that sounds really familiar. Oh, that's just like B. B said no more than 12. E said more than 12. Let's see, more than. Let's go look at our cheat sheet. More than, that's a greater than. That's okay. So we'll go back to our number line. We want more than 12. Okay, well, 12 is not more than 12. We wanted more than. Okay. 11 is not more than 12. Oh, 13 is more than 12 and 14 is more than 12. Ah, I need the right-hand side again. Oh, okay, so it'll be just like before where I'm going to use the left-hand side. I'll just take away all of this. If I subtract away all of this, then I'll get the side that I wanted. Yay! Awesome. Okay, clear away all that. So just like before, I want more than 12, so I want to subtract away 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All of those probabilities added up, subtracted from 1, will give us the probabilities that we wanted on the right-hand side. Equals 1 minus binom dot dist of 12, 20.64, and true. m. So this will take away from 1 everything that we don't want involved on that left-hand side. So it looks like anytime I need the right, I'm going to take away from 1. Anytime I need the left, I'm going to use the cumulative. And anytime I need exact, I'm going to say no to cumulative. I should start writing this down. Okay. F. Let's see. The probability that at least 16 adults flush public toilets with their foot. At least 16. What does at least mean? Let's go look at our cheat sheet. At least, at least, at least. At least. Oh. Okay, that's greater than. Okay, so let's try that. So if, let's see, if 12 people flush the toilet with their foot, that's not at least 16. So 12 is bad, 13 is bad, 14 is bad, 15 is bad, 16. If 16 people flush the toilet with their foot, then that's at least 16. So 17, 18, 19, and 20. Yay! Oh boy. Okay, this is exhausting. All right. So that means that I want to take away all of these. These are all the values that I don't want included. Okay, so I just got to do that one subtraction thing again. It looks like I'm going to do it for 15. Okay, I could do that. All right, so that means equals 1 minus binom dot dist of 15, because 16 was okay. 20 is how many people we asked. 0.64 is the probability they said yes. And then true, because I want to take away all the values to the left. Okay, we're almost done. We're almost done. As long as the last one's not tricky in any way, we'll be in good. Oh, it's super tricky. Oh. All right, we need a pep talk. Now can do it. Thanks. I feel a lot better, kitty. Okay, let's try this. See, between 11 and 8. Oh man, between, is between even on our cheat? Between's not even on our cheat sheet. It's not even on the cheat sheet. What am I supposed to do now? I'm gonna read it a bunch. Ah, okay. The probability that between 9 and 11, inclusive, adult Americans flush public toilets with their foot. Oh, okay. That's kind of giving away the answer. We'll just ignore that bottom part. Okay, between 9 and 11. I can do that on a number line. Sure, I learned that in algebra. So 9 to 11 is okay. And then is it these? Or is it the other ones? Let's see. It says inclusive, and I remember the I looking like a bracket for inclusive. Cool, so it's the brackets. Okay, so between 9 to 11, cool. Well, that's no problem. I know how to find the left and the right. This is between. Ah, okay. All right, let's try. We'll just try using the left for a second. Let's see. All right, if I try and find the left, of 11, that's all of this. Okay, I know how to find all of that. What else do I know? I know how to find the left of 9, and that's all of this. Oh, okay. Hold on, I'm getting an idea here. What if I take all the purple and I subtract away all the red? I take all the purple and I subtract away all the red. The only thing that would be left is this. Oh, and that's what I want. Yes. All right, cool. So I'm gonna take all the purple. Gotta figure that out. I'm gonna take all the red. I'm gonna subtract them. Okay. So, okay, I can do this. Kitty, are you ready to type? Yeah. That's probably a yes. Okay, let's go. So this is equal to binom dot dist, open parentheses, 11 is the number, the big one. Okay, and then 20 from the problem, and 0.64 for the problem, and the whole left-hand side, so true. Okay, minus all the red stuff. Okay, same thing, binom dot dist. Okay, 9, and then 20, and then 0.64, and then true. We did it, we did all the homework problems. We're done. Oh, that doesn't light up anymore. Okay, so that took a long time. We should probably try and figure out how to summarize that in some way. All right, I got this cheat sheet. I can probably roll with that. Okay, I'm going to try and figure out how to summarize this. I'll be right back. Kitty. Yeah? What's that? Does it seem weird to you that we have the same voice? I mean, not super weird considering that she's a teacher and not a puppet master, so, you know, pretty much that one voice to go with for puppeting. Okay, we'll just ignore it. I am a genius. I know. Okay, but can I explain to you why? I guess if you want to, but I kind of already knew that, so. All right, well, sort of takes the wind out of my sails, but all right, well, let's just explain it anyway. All right, go. I'll control the mouse. Not that kind of mouse. Okay, so if we look at the math symbols, they'll tell us whether or not it's right or left. How, you ask? Whoa, let me show you. Check this out. If we just turn them into arrows, they point to the left and right. Look at. I'm just going to add a drawing to this. Boom. What direction does that point? That points to the right. That means it's a 1 minus problem. Okay. What direction is this? Oh, that points to the right. That means it's a 1 minus problem. What direction is this? Oh, yes, that does in fact point to the left. Well, that just means it's a cumulative problem, so that's just a true problem. Boy, it's hard to write with a mouse. I said that, just for the record. I said it's hard to write with mouse. Okay, and then, okay, no more than that points to the left. What? Points to the left, so that's just a true problem. Okay, and last one. This doesn't point any direction, so this is a false. And that's how you answer that last cumulative input for Excel. Ha! The answers were right in front of us the whole time. They were pointing in the correct direction. If the problem is on the right, you have to subtract from 1. If the problem is on the left, I'm really bad at wiggling this arm, then you just use true. And if the problem's exactly, then you just use false. The end. Woohoo!